Hello, here you can see Dragon's hatch is closed, all communication and suit checks are complete, the seats are rotated, and the Fram2 are ready for launch. Here in this video you'll have the liftoff of Fram2 and the Fram2. Here the crew will become the first humans to view the Earth's polar regions from space and participate in a ham radio contest and record the sounds of Dragon, among other activities. After exploring the Earth's polar regions for 3 to 5 days, Fram2 will be the first Dragon human spaceflight mission to Splashdown off the coast of California. Dragon and the crew will launch to a 90 degrees circular orbit from Florida and travel to approximately 440 kilometers above Earth to explore the polar regions of our planet. Fram2 is also the second mission to fly with Dragon's cupola. The cupola is the largest continuous window in space, providing 360-degree views. The Fram2 will conduct 22 science experiments while orbiting the poles, all designed to help human health on future long-duration space flights. Among the studies is the first X-ray to be taken in space, growing mushrooms for nutrition, and long-term food sustainability, and evaluation of blood flow restriction devices to help astronauts get the benefits of strenuous exercise on orbit, accessing space motion sickness, and the first unassisted crew exit from Dragon after splashdown and recovery.
An Australian polar adventurer, explorer. I've skied 4 new routes to the South Pole. These are expeditions that I've planned myself. I've looked at satellite imagery of these glaciers that have never been traversed before, and I'm going to have the opportunity as we fly over Antarctica and see those routes from above.
The primary goal of this mission is observation, polar observation. There have been humans flying into space since 1961, and nobody's seen the South Pole, North Pole, extreme polar regions from orbit yet. We will be doing something that is quintessential to humans, and that is seeing things with our own eyes. It's my curiosity, like for years, what's Antarctica really like?
We don't know what we're going to discover. We are exploring a part of planet Earth from space that has never been explored. As a cinematographer, I'm excited about filming the aurora. That is a visual indicator for us to understand a lot about space weather. What does the aurora consist of? What's the density of aurora? And actually flying through the aurora, capturing this in both 2D and 3D.
What I'm looking forward to do in space, looking forward to the research that we are going to do on orbit. I would say we have 2 main themes. So one is how do people adapt to extreme environments? Based on that, how do you increase the access to space for anyone medically without being a superhuman as in the olden days? I think astronauts before us were absolute heroes, right? But then it should shift from that to how does anyone go into space? I'm super excited for a ham radio competition that we will host. The idea is that we have different pictures of locations on Earth in the polar regions, which are also of relevance to polar history. But then we cut them up, mix them up, and we're just going to send them down through the radio, and people have to puzzle them together in international teams. Another thing that we plan to do in space is that we're bringing a synthesizer, and we want to sample some sounds that we can hear in space, some of the thrusters firing, for example, and integrate that into one jam, I think, which would be pretty cool.
We know that photographs of the Arctic and Antarctica are available on Google Earth and through satellite imagery, but to see them from orbit may reveal things about these 2 areas, the Antarctic and the Arctic, that we have previously not known.
Some people may think it's a tourist mission. I don't mind that. It's up to you to define what's a tourist mission, but for me it's an exploration.
When we started thinking about the cupola, it's more than just another window in space. It's an extension of the Dragon spacecraft. So when we got into concepting, it has to have the same feel and aura of the actual Dragon spacecraft.
You are go to open the forward hatch for cupola use. and please enjoy the best view of the planet.
When the forward hatch first opens, you can look up and you see immediately that there's a large window up there with the 4 Draco shields protecting the bubbles from the Draco pulses. If you look at the videos from Inspiration 4, you can see their jaws all drop just looking out the forward hatch, not even being in the cupola.
The most notable thing to me is that it looks so simple on the outside, but the deeper you go, the more you uncover more complexities within it. There's 3 different bubbles that make up the cupola. The exterior-most bubble is our thermal bubble, which is designed to protect from micrometeorite debris that we could experience on orbit. The center bubble is the pressure pane, which holds in all the pressure, and the innermost pane is our scratch pane, designed to protect from anything that the crew inside might be doing.
It's actually made from acrylic and polycarbonate layers, but you also have technologies that are in, say, fighter aircraft that are applied to the cupola. We have a coating called indium tenoxide, which keeps the temperatures down on the inside of the cupola space. All these aspects are tested on the ground and made sure that we operate safely and that we know that when the astronauts are going up there that they have a great time. What makes this the largest window in orbit? It's just the overall size of it.
I feel like it's just so immersive, you're inside of the bubble and you're looking out and space is literally all around you. I think the experience of having the cupola on Dragon makes it such that Dragon is the experience. Even when we fly our short duration missions to the ISS feels like the destination and the experience, whereas having the cupola on Dragon really makes Dragon and being inside the cupola the destination.
When you get into the cupola, it feels almost like you're on a spacewalk. The Earth all around you, the stars, sunrise, sunset, getting up in there and looking out is a one-of-a-kind experience.
Throughout their first 2 full days on orbit, the crew took the first ever X-ray in space. 130 years after the first X-ray was captured, the Fram2 did a brain mapping EEG experiment and contributed to a continuous glucose monitor study examining how fluid shifts in space affect the accuracy of glucose monitors for diabetes. Chuan, Janicki, Rabik, and Eric also transferred images for Fram2 Ham, took conference calls in space, and were able to chat with their families thanks to Starlink. Nearly 4 days after the Fram2 launched to a polar orbit, Dragon and the Fram2 crew are set to return to Earth on Friday, April 4th. During their time in space, the Fram2 orbited the Earth 55 times, passing over the poles about every 46 minutes. After Dragon re-enters Earth's atmosphere, it will splash down off the south coast of California near Oceanside at approximately 9:19 a.m. Pacific time. This is the first Dragon human spaceflight mission to splash down off the coast of California, officially returning Dragon recovery operations to the west coast. You will also see once after the Fram2 splash down and the Dragon is safely aboard the recovery boat, the crew will exit Dragon unassisted to help researchers characterize the ability of astronauts to perform functional tasks on their own after short and long durations in space. Drogue parachutes are deployed. Dragon's 4 main parachutes have deployed. Splashdown of Dragon and the Fram2 confirmed will come back to the Earth. In this video, you will see the Fram2 flew aboard Dragon's 17th human spaceflight mission with 66 crew members, now having flown aboard the spacecraft and became the first Dragon crew to splash down in the Pacific. Here you will see the videos. Okay, thank you. Have a nice day.
Welcome home, Fram2. We have confirmation of splashdown of the Dragon spacecraft. Dragon has returned home with the Fram2 crew.
Here's your Radhika signing off with Till Loose.